Okay, now for the most complicated part, talking about nuclear fusion. Nuclear fusion is when you actually take hydrogen and helium and when they interact with one another. As you've heard over and over again, but maybe not understood, is that all elements within our solar system, including the things in which we have on our periodic table, all were created by when the process of hydrogen and helium had a reaction with one another. What takes place is that hydrogen and helium, when they merge together, they create energy. Okay, so they like to combine with one another, and when they combine, they create this energy which is given off in the form of radiation. Some of that energy is not necessarily converted into energy, it's converted into material. And those materials that are remaining are turned into new and other elements. So like most nuclear reactions, the reaction doesn't just take place in one step. It's a multi-step process for fusion to actually take place. All right, let's see if we can make some understanding of this. The reaction that takes place between hydrogen and helium produces a certain amount of mass. Okay, we talk about our body, for example. When we step on the scale and find out what our weight is, that factors in gravity. It's our mass, which is the physical being that we are, multiplied by the gravity on Earth, 9.8. Well, what happens in space is that we already know that the gravity on the sun is 28 times larger than it is on Earth. The mass of an element remains the same. So if you were to take out the factor of gravity, that mass, no matter where we put it in our solar system, would be the exact same. It would not change. The weight of that element would, because we would then multiply the mass multiplied by the gravity of each of those locations. So for example, if we were to take the weight of hydrogen here on Earth, the weight would be different on Earth than it would be in space in any other place, including the sun, because gravity on the sun is 28 times larger than the gravity on Earth. So the mass itself would remain the same. We just take out the whole idea behind gravity. So what takes place is that the reaction of energy, because helium it has less mass than hydrogen, it takes this reaction, and when this takes place, there's less mass after the reaction. So when these two fuse together, the mass, there's some of it which is lost, and any lost mass is converted into energy. That energy is what then travels out into space, better known as radiation. So the most common nuclear fusion that actually takes place is when hydrogen and helium actually combine. There are other examples, but this is the most common because these were the building blocks for all the materials that we now have within our entire universe, including the things in which you and I see when we look at a periodic table here on Earth. These reactions also provide energy for our sun, but also other stars as well, remembering that our sun is a star. So when the hydrogen runs out, what's going to happen? Well, if the hydrogen runs out, there's these heavier elements, like on a periodic table, like iron, that are made by nuclear fusion that takes place in these supermassive stars. And those supermassive stars have lots and lots and lots of energy to actually then create these heavier elements. So the question that you may be wondering or asking yourself is, where's the star that created these heavier elements that we have currently on Earth? It's a great question, and that's what scientists are, again, investigating and trying to find out. So the scientists are investigating exactly what caused these heavier elements, such as iron or other, to be formed and then end up on Earth. What they've now learned is that the fusion of atoms to create these heavier elements is when you, instead of release energy, you are requiring energy to actually create this. So where does this energy come from? This would be the primary example when you talk about when these supernovas take place, where instead of releasing all the energy that they would release is actually consumed. And when they consume it, it produces this massive eruption of material that is sent out to all places within our universe. So these actual reactions that take place is when you have a very huge abundance of energy. And the only way in which you find this amount of energy is when you have a star that explodes like a supernova, which will be discussed in the video that you're about to watch on slide 27, which will be your final thing that you will do here at this station.